Hi, we are now going to discuss equation formatting as part of our fundamental series. The purpose is to learn how to lay out an equation in your document regardless of the level of complexity. We're going to begin our discussion by going over our setup here. So if we look over here at our code, we've pre-established some variables and set up a namespace with some variables in it for use as we work through this concept. Let's go through this namespace first. Before I even start discussing the items in the namespace, it's important to know that it's not necessary to make a namespace to do what we're doing today. In fact, everything declared here in the namespace, including all these items declared here in the global space, these could all be made local variables inside of the class for the document that we're working on. The reason that we're setting these particular items aside in a namespace is to illustrate that we might, in some cases, want to make those available across multiple different files that we're using to build out a larger document. And so we want to make those globally accessible and then identified under the name symbols. So we would access anything in this namespace by typing symbols.x, symbols.y, symbols.imaginary number, anywhere in this application. Now what I've done is I've taken symbols and I've placed it here in our using statement at the top. By doing so, in this particular file, I don't have to reference all of these names by putting symbols in front. All I need to do is type the name because symbols is here in our using statement. So with that out of the way, let's take a look at symbols. So a symbol sets up an object for use in an equation. So if we look here, if we hover again, we look at the parameters. The parameters are symbol and a nullable description. So here we have X is going to be the symbol. That is what will show up in the document. And this here is the description. We'll see how that comes into play in just a moment. And then X is the variable that we're going to use inside of our application. Now we've declared a number of these symbols here. We have a Schrödinger equation here, and we've declared a number of symbols here also. And then we have some global variables that we've declared here, and we're going to explain these more as we work through these concepts. First thing we have here is our topic. And in this document, we'll have a topic line, which has nothing to do with the equations. It simply places this little green label in the document so we can reference the content that comes after it. And then we show X. X is the variable up here that we declared under symbols. So X is a symbol, and it shows up in the document like this. It's important to note that when something is a symbol causes it to use the font that is specifically associated with symbols in Nitral. Nitral has a font that is used specifically for symbols. It has a font that is used specifically for equations, and one for math, and one for a serif font, etc. And those can all be overridden. Right now, we're just going to use the default font for symbols. And that's what shows up right here. That's what we're seeing in our document. And I'm going to go ahead and zoom in now to make it easier to see our content here. And I'm even going to zoom in on the code to make it a little easier for all of us to see. And now I explained earlier that in X, we have this description. That description is there so that when you or others are looking at an equation that has been built in the document, you have the option to hover the mouse over one of the variables in the equation and learn a little bit about what that variable is in there for and how it is supposed to apply to the particular equation. So in this case, we just call this independent variable X, and there we go. And so setting up symbols is really the fundamental concept that must take place first before laying out equations in Nitral. So let's first take a look at a fraction. Right here, we're using the fraction keyword, and simply enough, we have two elements in the fraction revision. The first element is always going to be the numerator, and the second element is going to be the denominator. It's that simple. So if we take a look here, we see that we've given a parameter to fraction. So let's take a look at a fraction, and we can see at the top of the screen that we have diagonal and compact are the two parameters that you can use when setting up a fraction. So this true means diagonal. So if we take a look over here in the document, we can see what happens when you set a fraction to diagonal. It lays it out horizontally with the diagonal slash. And then here we're laying out a fraction using diagonal true and compact true. So when we look at that on the line here, we see 1/x inside this line of text. And we can change that diagonal to false and run it. And now it just shows the fraction stacked, but still compacted so that it fits in with a string of text rather well. Okay, moving on with simple concepts. Let's take a look at radicals. So here we have a simple radical. And if you just put one element in the radical revision, that element will become the radicand, as you see here. And then, simply enough, a radical can have a degree property. In this case, we're setting the degree property to a 3. And then the radicand, we have y plus x. So you can see that the 3 shows up in the proper position here, and y plus x as a radicand. Very briefly here, let's just take a look at superscripts and subscripts, as those are used quite often in equations. So as a shortcut for adding a superscript or a subscript, we can use the sub keyword. So we can show that as x sub 1 or y sub 2, and they show up in the document as you would expect. Superscripts, however, look quite similar to powers. The difference is that when we use the caret symbol, we're actually raising the variable to the power of 4. So if I were to put here 2 caret 4 F5, I'm going to get the actual 2 raised to the power of 4. So this is y raised to the power of 4, and since y doesn't have a value, then it shows it as an equation instead. So we get y to the power of 4. Now we're going to show several examples of how to use the n-ary formatter. So first, let's just talk about the n-ary and its parts. So here we see on the screen, we've got this n-ary laid out, and here's how it is set up. Pre-upper, 1, pre-lower, 2. That's the 1 and the 2 shown in this position here. We have the operator, O, and then we have our upper and lower 3 and 4, which are shown here in these positions. And then finally, we have the body. The single element here in this n-ary is the body, and that shows up to the right. So with the basic components out of the way, let's take a look at some n-ary implementations. So here's an example of a simple chemical formula. In this case, we have an n-ary set up with the O2, with the 2 being in the lower position and the O being here. So we have O2. And then we take that n-ary, assign it to a variable, and make it the operator of another n-ary. And in that other n-ary, we give the upper a minus sign. And so we get O2 minus. So here's another example of using n-aries to put together a formula. And in this case, we're working on this nuclear decay formula, and we've got our rubidium shown here, rubidium 87, and we put the 87 in the pre-upper position. We do the same thing for the strontium 87, and then for the beta, for the negative beta particle, we just use the sup keyword, and in this case, just use a dash. So we get this nice layout here. So in this example here, we've actually taken some steps to make it a little easier to write our equation. We've set up this isotope method that takes the parameters. We have the mass, the atomic weight, and the symbol here. And then we also have this decay method that we use to set up these arrows with the symbols on top. So if we just take a look, we'll press F12 on this, jump up here, and we can see we set this isotope up. We've got weight, element, and name, and that is setting up an n-ary. It takes pre-upper, pre-lower, and operator. And that's what we have set up right here, right? Because we have 3 of those. One here, and one here. And then our decay, which is this thing here, we set up a simple little V box so that we can have the symbol over the top of the arrow. That's a vertical box, and that's what it does. So that makes it pretty simple to make our equation readable. We put these things inside of an H box, and we set up our thorium, followed by the alpha decay, and then we have our radium, followed by the beta minus decay, and then we have our resulting actinium. Okay, so another thing to know when setting up n-aries is that there are certain operators that require special handling, and Nitrile knows which ones they are, and when they're applied to an equation, they're dealt with in a special way. For example, here we're showing this integral symbol, which you can see in the equation is stretched out to fit the size of the equation. And there are several different operators that will do that. So I'll switch this to integral 4 and switch it back. So that is one concept. The other concept to discuss is text equation property, which we have not introduced yet. So the text equation property tells Nitrile to set everything up inside of this as an equation to start with. So it formats it all properly as an equation. And it also sets everything up in this particular revision to use the font that is set up for equations in Nitrile. So if we take out this text equation here and press F5, we'll see that some of the symbols are now formatted to whatever the default document font family is. When we place that back in, everything is now formatted properly and evenly as an equation. Just as I said with the integral operator, there are others. In this case, it's the sum operator, which is oversized. But in this particular n-ary, we're also applying the text stacked property. That causes the upper and lower options of the n-ary to be placed in these positions here. Pretty straightforward. And then, of course, the body follows to the right. Okay, so moving on from n-aries, there's a couple of additional concepts I'd like to discuss regarding equation formatting. And the first is to consider, as we reviewed earlier, to use variables to hold parts of your equation. You've seen some of that already. You'll see more of it later. In this case, we're just setting up a simple f of x operator for our equation. And then here in this paragraph, we set this paragraph up as a text equation. And then we use the variable here, f of x. Then we say it equals all this stuff, and then that's what shows up in our document. Pretty straightforward. And quite often it will be the case when you need to mix an equation with text. And Nitrile has the ability to do that if you use certain features. In this case, it's pretty straightforward. You make the whole paragraph a text equation, and then we give it the text. We give it some part of an equation such as this fraction here, and then and then again we have this f of x, which we're reusing, equals the rest of the equation. So that's a good example of how to mix equations with text inline. Another concept here is setting up a simple matrix. We call that a matrix box. And a matrix box has rows of content, and inside the rows are cells. And when you give it data, such as we're doing here, it just automatically lays it out in a matrix. Now, this particular matrix is surrounded by brackets. That's because we added a bracket property. If I take that out and F5, then there's our just straight plain vanilla matrix. The bracket that I'm putting in here is called brackets square, and that applies these brackets that size themselves to the content and surround it accordingly. We'll take a look at more brackets as we work through some additional examples here. So in this next example, we're again using a matrix box. And in this case, we're just giving it these two symbols that we defined in our symbols namespace, X and K, and we're surrounding those with a round bracket. The other point of this particular equation is that we're putting it in an H box. You're going to find that H boxes, and in some cases V boxes, are used commonly to put together equations. So in this case, this H box has three elements: a matrix box, an equal sign, and a fraction. And the H box lays those out horizontally, as you can see right here. Okay, so just a couple more examples of brackets. So here is a bracket called curly, but after the bracket, we've given it this dot left. So we can see in this example number 20 here that we've got this curly bracket located on the left of these three rows of content. Again, we have a matrix box with 3 rows of content, and we gave it this curly bracket. By default, a bracket has the left-right property set. That's why brackets round here and brackets square here showed up on both sides, because that is the default positioning. We can obviously override that by adding a dot location item to the right of the bracket. So here we've got dot left, we can do dot right, and that moves it around. And then similarly, as we see here in item 21, we have bottom. So we can do top and bottom or top and bottom. In fact, I'll show that here. We can do top and bottom. And now we've got the curly brackets top and bottom. So now we're going to talk alignments. Alignments essentially line up equations on a character, as shown here, the equal sign, and they number equations for us if we want them to. Some articles, such as journal articles, require that equations be numbered throughout the entire document. And that's why we set up an alignment normally by assigning it to a variable without any particular content in it yet. So here we've set an alignment class to this align variable. So let's take a look at an alignment. I'm just going to press F1 here. We can see that it takes an enumerator, a start, aligners, and a gap. So the enumerators are here, and we're telling it use numbers and parens. That's what we're seeing over here on the right is a 1 separated by the parentheses. Number parens, that's what that is. The next item is start, and we have that set to null right now. Essentially what that means is start at 1. If we set it to 5, it'll start at 5. So if somewhere in your document you need to start the numbering over again, you can create another alignment class and change the start number so you can pick up where you need to. And then finally is the character that you want to align on. And in this case, we want to align on the equal sign. So then we take this align variable and we revise it and we start giving it content. So in this case, we just give it a simple paragraph, E equals MC squared, and then another one with an equal sign also, and it will automatically align them on the equal sign. Okay, so let's set this back to null so that it doesn't restart numbering. And let's add in some additional content here. So now we've added in more explanation, which is just a straight paragraph here. And then under that, we use the align variable again, give it a couple more paragraphs of content, and we can see that Nitrile aligns all of these up on the equal sign, and it numbers them continuously throughout the document. Okay, given all the things that we've discussed thus far, we're going to go ahead and discuss the complex layout of this one-dimensional Schrödinger equation and how we've done it here. Now, several of the variables and symbols that I'm using for this Schrodinger equation are up here declared in the namespace, in the symbols namespace. So for example, I'm putting together this imaginary number that I'm going to use this actual variable in the equation, but it's represented as I in the equation. I apologize. We're going to use imaginary number in the code, and I is going to be used in the equation. And in this case, instead of just giving it a simple description, I gave it a complex description, and then I'm giving it some text followed by a radical of -1. That way, when somebody wants to take a look at this equation, they can hover over I here and they can see that, okay, I is imaginary unit, square root of -1. So we have all these symbols set up here that we need to use in this equation. And then I've got some variables declared here. Now these could also be done globally. If you were to need to use these in other equations throughout your document, it would make sense to put them in a namespace or just put them up as global variables. But in this case, I just made them local. And I divided up the different areas of this particular equation, the different functions of this equation. For example, here is the partial derivative with time. And then we use over and over again this left parenthesis x comma t right paren. So I have this here as a simple variable showing that layout. And then we have a wave function here. And then we have our potential energy here. And then we have our kinetic energy. Oh, and by the way, the wave function isn't just used here, it's also used here at the end of this equation. So you can see by declaring these things here, this is going to be pretty simple to put together. And then we have our kinetic energy, which is all of this here. And so putting together the equation itself becomes relatively simple. We simply make an H box if we lay things out horizontally. And then we start adding in our items. We have our imaginary number. That's our I here. And then we place in our H bar. And then we have our partial derivative. And then this wave function here. And then we have an equal sign. Then we throw in another H box and we put around it square brackets. Right? That's perfect. And in there, very simply, kinetic energy plus potential energy. Kinetic energy plus potential energy. And then right outside of those brackets, we put another wave function. And this is a simple layout for this rather complex equation. But what's nice about it is that it's much more maintainable than, say, just a big string of text characters when you have to come back and look at it later and you're trying to, figure out where something went wrong or what else you need. It's much easier to go and work with the equation when it's in this object-oriented layout. Also, in Nitro, you can hold down the control key and click on certain characters inside of an equation, and it will take you to that point in your code where that particular thing is coming from. So these brackets are coming from this H box. So this 2 in this x squared is coming from right here. And so that also is a very useful feature because you can go from your document back to your code, get right into the code that lays out the equation and make whatever changes you need to make. Okay, so that's a pretty good overview of how to use equations in Nitro, or at least how to lay them out in your document. Hopefully you find this helpful. If you have any questions, comments, concerns, or anything else you would like to discuss with us, please reach out to us on Discord. You'll find the link for Discord in the description box below. Thanks for watching.